we have seen divisibility rule for 2, 3, 4, 5, 6 and 9, 10. Now let's see for the remaining numbers. If we see, if we go for a divisibility rule for 12, we have already seen. If we want to go for a divisibility rule for 14, that means if the given number is, whether the given number is divisible by 14 or not. To check whether the number is divisible by 14 or not, just check the given number. Just check whether the given number is divisible by 2 and 7. That means the given number should be divisible by 2 and 7, then the whole number will be divisible by 14. Now next, let's go for a divisibility rule for 25. If you want to see whether the number is divisible by 25 or not, just take the given number. That means, for example, if 625, it is actually divisible by 25, but let's see if whether if you want to check whether 625 is divisible by 25 or not, then no need to divide it by 25, just forget this and just multiply this with 4. Whatever the result you get, that will be the answer for divisibility rule. And next, let's go to the divisibility rule for 7, 11 and 13. There is just one common divisibility rule for 7, 11, 13. That means whether the given number is divisible by 7 or not, or 11 or not, or 13 or not. There is a common rule for this 7, 11, 13. So let's see that common rule. For example, if I have a number like if I have a number, if in our examination if they give 7, 2, 3, 4, 1, 9, 7, whether this number is divisible by 7 or not. That is one question. Whether this number is divisible by 11 or not, whether this number is divisible by 13 or not. For all these three, 7, 11, 13, there is one single rule. Let's see what is that single rule. I want to check whether this number is divisible by 7, 11, 13. So for that, just start from left hand side, right hand side, and divide this number. That means make this number into 3 compartments. Like this 197 is one compartment and 234 as one compartment, right? Now just take an alternative numbers. Alternative numbers in the sense 197 and this 7. These are alternative numbers. Add this alternative numbers. 7 plus 7, 14, 4, 10, 204, right? And whatever the resultant number you have got, from that number, just take this 234 number, leftover number. If the number is still proceeded, then you can take this alternative number and you can add. As we don't have any number, I am just taking this number single. 234. From this 234, just subtract the number which you got from here, 204. So you will be getting 30, right? So check this 30, whether this 30 is divisible by 7 or not, and whether this 30 is divisible by 11 or not, and whether this 30 is divisible by 13 or not. So it is difficult for us to check whether this complete number is divisible by 7, 11, 13 in a limited time. So to avoid that kind of long calculations, we will just minimize like this. Just take the number, whatever the given number, start from right hand side, divide the numbers into 3 compartments. That should, in one compartment there should be 3 numbers. Like that, divide the numbers starting from right hand side and take the alternative numbers, alternative compartments, and add them first. So here I have only 2 alternatives. So I have added 197 plus 7, and other alternative I don't have any other number which is which can be added for this. So I left that like that. So I have taken this number and added to this, whatever the resultant number I got from that, I am subtracting this 234 with the given resultant number, whatever the number I got. So after you subtract whatever the result you are getting, that result should be divisible by 7. If you are checking for divisibility rule for 7, this resulting number should, whatever the 30 you got, that should divisible by 7, then the number will be divisible by 7. And whatever the number you are getting, that should divisible by 11 if you are checking for 11, and whatever the number you are getting, that should divisible by 13 if you are checking for 13. So from this, overall from all this, we got a conclusion that this whole number is not divisible by either 7 or 11 or 13, right? Just to avoid that long calculations, we are just following this simple process. So now let's move to the next thing. We are done with the divisibility rule for 7, 11, 13. There is one special case where you generally come across this kind of problems, that is divisibility rule for divisibility rule for 37 and 27. So we are just checking whether the given number is divisible by 37 and 27. The rule is common for both 37 and 27, like how we got common for 7, 11, 13. The rule which we are discussing now is common for 37 and 27, right? So let's see how we can go with this. If you got a number like, if you have this number, if you go for this number, if you want to check whether this number is divisible by 37 or whether this number is divisible by 27, you can follow one simple method. Here the method which we are following is same as like the method which we follow here, but we have just subtracted. Here you should just add. The same process we will follow here. Starting from right hand side, just divide all the numbers into divide the numbers into 3 compartments. The compartment should have 3 digits in it. So 3 and 3. After that, if you want to take alternative or if you want to add all them, you can add all them. That means 724 plus 176 plus 6. 12, it is 18. 16, 6, 1 and 7. So I am getting around 906. So 906, this 906 number, even that if this 906 number is having, for example, we are taking an example, if even after adding, if I got not only 906, I got 9061. Assume that even after adding I got 4-digit number. Then also you can divide this number into 3 compartments, 3 digits in one compartment. Then again you can add that and make it into a 3-digit number, or else you may be getting a 2-digit number, right? So now here we did not get 4-digit number, so we are left with 906. Now check whether this 906 is divisible by 37, or if you are checking for divisibility rule for 37, just check 906 whether 906 is divisible by 37 and whether 906 is divisible by 27, right? Instead of going for a complete number divisibility, if you want to check complete number divisible, whether it is divisible or not, so to avoid that calculations, we are just minimizing this and we are getting an answer by just divisible, just by taking a simple rule or trick, whatever you can say. So this is how you can go with divisibility rule for 7, 11, 13 and divisibility rule for 37 and 11. Let's move to the next thing. And we did not discuss about the divisibility rule for 8. If you want to check whether the number is divisible by 8, just check the last 3 digits must be 0 or the last 3 digits must be divisible by 8. For example, if you got a long number like this, if you want to check whether that number is divisible by 8 or not, just check whether the last 3 digits are 0. If the last 3 digits are 0, then the number will get divisible by 8. Directly you can give the answer. Or if just check with the last 3 digit numbers. If last 3 digit numbers are divisible by 8, then the whole number will get divisible by 8. So this is the divisibility rule for 8. So let's move to the next thing. Let's see whether this number is let's see what is the result we are going to get if this number is multiplied by 11, right? So if you are multiplying that whole number with 11, it will take lots of time. To avoid that, we will get an answer just in a single step. Let's see how we can get the answer in a single step. So we are just multiplying this number with 11. Just concentrate on this number. Just simply neglect this multiply 11, cross 11, and the method which we start is from right to left. We start applying method from right to left. So first, whatever the digit you have, just write the digit as it is, and next add these 2 digits. You will get 3, write that 3, and next add these 2 digits, you will get 5, write 5, and add this next 2 digits, it is 7, and add these 2 digits, you will get 9, and add these 2 digits, you are getting 11. So just write 1 here, keep 1 in mind. We should not write 11 here, just keep 1 here, keep 1 in mind. And next, if you add these 2, you will get 14 plus 1, 15. So write 5 here, again 1 in mind, right? Next, if you add these 2, you will get 15, 15 plus 1, 16. So 16. So we'll write 6 here and keep 1 in mind, right? We are done only till 7 plus 8. And last, whatever the digit is left over, 7. For that 7, just add this number, whatever we are left with, that is 8. So 865197531 will be our answer. If we want to multiply this number with 11, we'll get this number, right? So just to avoid all the long steps, we can go with this multiplication. You can try taking a different numbers and you can try how easily we can go with this. And next, let's see one simple thing which we generally come across in any examinations, generally in competitive examinations. Multiplication by 999. Or you can even take 9999. The number seems to be very big, but when you go for a calculations, it is very easy if you know the concept. Here we take any number. If I have this number, if it is given like 87561, if you multiply this number with 999, what is the result you are going to get? The question is like, if you multiply this number with 999, what is the result you are going to get? To this, you will get an answer in a very single step if you consider in this way. If you write, if you arrange them in this way, 87561. As we have 3 nines here, that means 999. So just write 3 zeros here. And just down to this, write this number as it is from starting from right to left. That means 1, 6, 5, 7, 8. Just after arranging in this way, just to subtract this number, you will get around 87473439. Right? If it is for 999, just take 3 zeros. After this number, just write 3 zeros and write the same number under this number and subtract that number, you will get the result. If it is for 99, 87561, if it is for 99, just take 2 zeros. That means 87561, 2 zeros. Under this, just write the same number 16578. Just subtract, you will get the answer. If it is for 4 nines, you can write 4 zeros. If you observe here, what is the actual logic why we are taking 4 zeros there if it is if it should be multiplied by 999. If you observe, 999 is 999 is very close to 1000, right? So we are making this number to 1000 and subtracting just one number from it. That's the result we are getting here, right? So this is the actual concept here. So wherever it is asking for the multiplication with 9, if it is 9, just write 10 after that number and take the number same starting from 0 and subtract that. If it is for 99, take 2 zeros, 999, take 3 zeros, 9999, take 4 zeros and write it in this form and subtract, you will get the answer. This is the process for multiplication by 999, 9999. So let's move to the next thing. When we are discussing about divisibility rules for different numbers, we have written that DR there, and we have already discussed that. When we are coming across that, we will discuss what is that DR is. Actually, it is a distal root. Generally, commonly, not only commonly, if you know the concept of distal root, where lots of problems in number system can be done very easily. Actually, what is distal root is, for a given particular number, you have to cancel all the numbers, cancelling in the sense, make the sum of 9 of any, add any 2 numbers or any 3 numbers and make the sum 9, and you can cancel all the 9s. And that means for a big particular number, we are just making it into a single digit, single digit. Like for example, if you have I have this kind of number, so if I want to get the distal root for this number, just cancel all the 9s and whatever the leftover number will be there, that will be the distal root of this number, right? Distal root or distal rule, right? So just cancel all the 9s. 8 and 1 I can cancel as 9, and 7 and 2 I can cancel as 9, and 4 and 3, 6 and 3 I can cancel as 9, and 4 and 5 also I can cancel as 9. So here distal root will be 0, right? So like this, for a given particular number, you can find out the distal root. Just for a big number, just cancel all the 9s, collect all the 9s from the number and cancel them. At last make it as a single digit. Then that is called as a distal root for that, distal rule for this number. Actually it is, you can call it as distal root or distal rule, whatever it may be, right? Let's move to the other concepts. In number system, we have to go for some formulae because we will be having big calculations there. simplifications or calculations. So even for that calculations, to avoid that calculations, if we have a basic formula concept, then we can avoid that big calculations and we can go and apply that simple formula and you will get the answer. So let's see what are that important simple formulas. First formula we can take it as sum of n natural numbers, sum of squares of n natural numbers. We can represent this as sigma n square. So our answer will be, like for example, if I have 1 square, 2 square, 3 square, 4 square, so on until n square. So sum of squares of n natural numbers, that is sigma n square, will be n into n plus 1 into 2n plus 1 divided by 6. This is the formula. Sum of squares of n natural numbers, sigma n square, will be n into n plus 1, 2n plus 1 divided by 6. Here n will be the last number in the sense this will be the n value, right? Next, sum of first n natural numbers. We can represent this as sigma n, sum of first n natural numbers, that is it may be 1, 2, 3. Natural numbers will start from 1, so 1, 2, 3, so on up to n. We can take this as n into n plus 1 by 2 will be the formula for sum of first n natural numbers, n into n plus 1 by 2, right? And we have last formula, sum of cubes of first n natural numbers. Sigma n cube, you can denote this. So most probably 1 cube plus 2 cube, 3 cube, so on up to n cube will be n square into n plus 1 whole square divided by 4.